And the idea is that obviously the audience is around the globe, I guess. So today we'll aspire to give you a little bit of an insight into the work we're doing in IoT within the BT Ireland Innovation Centre, but specifically in the context of a trial we're running with a local customer, Belfast Harbour. So I've addressed the topic today as IoT Autonomics, which is actually a little bit more technical title, because it is actually what it is we're using as a way of advancing IoT in research. It's all about, autonomics and making things a bit more self-initiated, self-managed. We're going to be touching upon that in a minute. Let me just say a couple of words about BTIRC first. So BTIRC is one of 5 or 6 global research centers that NADER is running. It is based in, well, it's a collaboration actually between BT and Ulster University. It already ran its first 6 years of life, and it's currently funded for a second period, another 5 years, which was already started since April. And currently, as we speak, we are seeking to extend the government funding from Northern Ireland's government research agency, Invest in Northern Ireland. It's a proposal that's currently with them, and we're trying to, it's assessed now with the auditors there, with the Invest in stakeholders. So today I just going to be doing this piece with in collaboration with my colleagues Andrew and Brendan, and the spirit is to give you an idea of the business rationale and vision. So what is BT doing currently in IoT, and what is the vision we're having in research, as the next steps in that area, which is going to actually lay the foundation for the work we're doing. Which is we call it IoT Value Added Services or IoT Autonomics. I'm going to contextualize it, all the research we're doing, all the outputs, in the trial that we're doing with Belfast Harbour, and then I'm going to hand over to my colleagues, and some part I'm going to cover with regards to demos. We're going to give you some live experience of the capabilities we're developing. And therefore, I hope you enjoy it. Right, so it's going to be a very lively, event, in terms of the experience. We're open for questions. I would guess, we'll have plenty of time within the hour to cover any questions you want. You have any further, details you need. But obviously, well, there, offline, if you want to reach out to get more insight into specific areas you might find interesting. Based on personal interests you got. So if I kick it off in terms of the real presentation, then. So this is actually a slide just to put the context in front of you with regards to what an IoT architecture looks like, right? So with IoT, what we're trying to do is we're trying to use sensors, physical little devices we deploy dumb or smarter. We deploy in environments we want to monitor in the physical field. They collect data, different types of data. It can be time series data, events, it can be video streams. So from the sensors, from those environments, and over particular connectivity, either 5G or IoT specific connectivity like LoRa, MP-IoT, etc., we're pushing this data from the edge to an IoT platform, data platform that collects it. And in specific within BT, we have the data exchange as the data platform we push, the IoT platform, BT's IoT platform we push, which collects the data. Specifically, data exchange is doing, it's not doing video, it's doing any other content, but not video. Yeah, but it's what constitutes now BT IoT platform. It's a brainchild of research, which started within research about 10 years ago and eventually developed to be what we're selling to customers now as a BT platform. And from there, we're driving applications which are now smarter, because the idea of data exchange is to provide a data layer between the sensors and the applications. Traditionally, applications would have a bunch of dedicated sensors to collect data, application-specific data. So application and a set of sensors, another application, another set of sensors. That would be traditionally the way you build IoT apps and services. Now, we want to snip those strings connecting specific sensors to specific applications and detach, disjoin the two layers such that we can say, collect as much data as you want with whatever sensors you want, because before you might have had redundancy of sensors, repeated sensors, which now you say you don't need this redundancy anymore. You just put the types of sensors you want in the field, collect the data in data exchange, and then develop applications by subscribing to certain data feeds you want to pull out of the data exchange. And therefore, you can make smarter applications without really depending too much in a closed system application and sensors directly. Okay, so that's the real novelty behind data exchange. Obviously, data exchange is much more complex than that. It's doing a lot of data-specific processing, monetization, etc. in the back of it. But let's keep it at that for the moment. And finally, there's different types of users tapping into applications to make decisions, to control real-time, critical mission critical applications, mission critical processes, or just statistical history, what's going on in certain areas for statistical purposes. So this is actually setting the scene of how IoT is built. So if we present that in a sort of layered kind of fashion, you see, like, again, we sort of turn it around like 90 degrees, and we start from sensors, we have networks, we have the data exchange, the IoT data platforms with BT's data exchange, but obviously we have AWS having its own IoT core. Up until recently, we had Google, we have Azure, etc. It's a customer choice what they want to have, but eventually the data makes it to a platform and you drive different applications. And as you have this particular setup, you can actually start copying and pasting this setup, using this setup in different verticals. So you want to drive different verticals, and therefore you scale the whole thing up to drive things like smart cities, use cases, smart industry 4.0, smart ports like our case in Belfast Harbour, health, smart X standing for any kind of domain you want to control. Therefore, by increasing the application, the applicability of this architecture, what you get is bigger scale, bigger complexity. And the key question here is, how can you manage that, right? If you start small scale, you'd say, I can drive a lot of that manually. I can have a lot of human intervention, administration by human hand, the human hand, coming in to help. But if you scale it all up, the complexity going up, you can't depend on human intervention. You want to go more independent. And that's how actually we're driving this vision for autonomics, where by autonomics, we want to start thinking about these self-X capabilities, self-configuration, self-optimization, self-healing, all these kinds of X capabilities that are injected in the platform and can drive the platform by itself. So the platform itself becomes self-managed, self-serviced. So that's the vision. We want to manage the complexity, and we want to enhance the automatic element of managing this platform, decreasing as much as possible human intervention for that management. The management concerns. So that's the vision. In order to deliver the vision, we want the strategies, we want to introduce this extra layer of value-added services. We call them value-added services because we're building a set of capabilities that are actually looking to engage the latest in machine learning, AI, all sort of intelligent capability that the machines can think of them by themselves, can learn from the past, can learn patterns, can do advanced algorithms and techniques so that they can actually self-balance the system when complexity and management complexity increases. All right, and this is really the key motivation for our work, is developing IoT value-added services for and make propositions to the business about how we view that area developing in the future. There's three types of dimensions in this area of IoT Autonomics, IoT value-added services. One is purely around the management of devices and application services. Another category of capabilities, self-X capabilities, is around the content itself. So we want to make the content to provide us richer and more valuable insights, more value out of what we collect from the field, so we can make smarter decisions around the domains we're monitoring. And finally, an overarching layer is dealing with SLA management. This is an area which is still we pioneer. It's very, very. We're not aware of anybody else looking at SLAs and IoT. We've been looking in this area for a number of years now, and we've been starting to implement some POCs, proof of concepts, as part of the trials, as part of our thinking process and design processes. So that's the key dimensions. And in this slide here, we show top-level view of the number of capabilities we are developing in BTIRC. As a whole group of them, we call it Matrix. Matrix is like a platform, an IoT platform, which is very scalable. You know, it can be deployed on top of the IoT data platforms, you know, whichever choice of platform a customer is doing, something that is pluggable and plug and playable on top of any kind of application. It allows all these capabilities to be exposed to a catalog and dynamically be deployed on demand and at will, very flexibly and in a scalable manner. And those acronyms here, those names here, are representative of the specific VAS that we are developing in BTIRC. Examples of which we're going to be talking about demonstrating to you as the presentation develops today. Few words around so we're developing VAS, we're developing value-added services, we're to prove the point of autonomics, the point of self-management, self-managed IoT architectures. But those are POCs, those are concepts, right? So now with BTIRC, we are trying to actually bring them ideas closer to the real world. And the best way to do that is with trials with customers. So we are part of a specific collaboration that BT have, the BT business have with Belfast Harbour, our customer. And so where we're going in and actually deploy commercial solutions to prove the value of those solutions in the customer's field. Specifically, we're deploying BT data exchange, we're deploying 5G networks, BT surveillance systems, which are the commercial solutions. And on the side of that, we want to help the customer understand and paint the future, understand where and how they can further enhance and digitally transform their domain to make it more self-managed, you know, to achieve exactly the vision I was talking about. And it was the best idea, the best way of actually bringing the two worlds together. From our point of view, put the ideas and concepts into the field and try to understand the pain points, where we need to do more work, and from the customer's perspective, to actually help them, as I said, you know, to understand the vision and the strategy of how to become innovative enough and facilitate digital transformation into the future. This slide just gives you a little bit of understanding of the size of the problem, the size of the domain that we're trying to deploy this kind of stuff. What I just want to make sure that I'm focusing on a little bit is that Belfast Harbour itself is not just one single authority, a single tenant. It's hosting, it's a small city, really, small smart city. It's hosting hundreds of other businesses, tons of people who are under different authorities. So it's a multi-tenanted environment. And that makes the complexity problem much bigger, because not only does the port offer underlying infrastructure, connectivity, networks, sensors to facilitate a backbone of IoT infrastructure, but those guys, those extra tenants, come in with their own infrastructure of IoT, their own sensors, their own devices, their own people who are using the facilities of the port. And therefore, we have to have ways of understanding that, considering that some of these particular, you know, subdomains, segments are private. You can't just break into their environment and understand the whole plurality of what they do. There might be, you know, points where you can see actually a certain amount of, but not the whole thing. Therefore, we need to have this kind of autonomics to work out as much as possible the patterns, the demand, the types of services they require, and help the authority, the single authority, the harbor, the port, facilitate as fast as possible through SLAs as well, through service level agreements as well, the IoT services that those tenants want to use. So moving on, I'm going to give you, this animated slide is trying to just to give you a little bit of an idea of how these value-added services would work, this matrix would work, assuming a catalog of rudimentary content base. Remember, we had 3 dimensions in the autonomics here. This example, this animated slide is trying to give you examples of value-added services that are more focused on the content manipulation, right? So in here, we're talking about video analytics, which can drive, and also analytics, combined analytics of video and other sensor data like environment data that in combination can give you richer understanding of what's going on and drive interventions if needs be. So some of these particular examples, we're going to see how they work more vividly in a minute of the real demo. So as you have, for instance, cameras deployed in the port, surveillance cameras, thousands of them, you're going to be driving the streams in the back of those cameras so that you are having different cohorts viewing these video streams. So the video streams come in and they're pulled out through a viewing application for different cohorts. You have security guards. You have plain Joe, plain public walking down the street and wanting to see, some public views of cameras that allows it. Or you might want to actually, you want to get different other services, view specific feeds. And therefore, because the cohorts are different, privacy comes in. In the video streams, you will see different objects, different level of privacy. All right. So you might see people's faces, you might be able to see cars, but not everybody of the viewers should be able to see. For instance, a security guard should be able to see everything because obviously they are of higher priority to intervene if something goes wrong. But if it's plain public, you might want to hide more private information. You might want to hide, for instance, car number plates or people's faces going down the street or anything of private nature, and just keep them seen, like it's very busy area. Public is, public is going down a certain area of the port for a certain reason. It's very busy in certain areas of the port, etc. You don't need to show those, more private information to them. And as you go on, you see that you want to deploy certain capabilities like privacy protection capabilities, which we call anonymization, depending on who is the viewer group. So we've been developing a VAS, which we call video anonymization, that in the video stream, real time, or as a playback out of saved streams, you can actually hide certain private objects in the stream, depending who the viewer group is. So for plain public, you might be able to hide the people and cars. For the security people, you hide nothing. For a case where you got a stream coming in, and then you realize that it's a scenario of health and safety, really, this particular one. You have services, not only video streams, but actually say, I have video analytics recognizing people falling over. And therefore, you might want to intervene, send the first aid out or the ambulance out to take care of them. At the same time, obviously, respecting the privacy, not showing, who they are. Or can be scenarios where certain staff might say, look, I'm not happy to be traced around on cameras. Therefore, keep my anonymization, please keep me anonymized. However, if you think that I need to be alerted for certain reasons, because, for instance, I'm asthmatic, and might be going into areas where certain gases, concentration of gases are high, and they could trigger my health problems, I would like you to alert me. Therefore, you might have more complex video analytics and combination of analytics over other data, like gas concentration, like environment sensors. So the two combined together, all these are strung together so that whilst we respect privacy, we're able to actually understand if somebody having health problems or HNS sensitivities, entering areas that need to be alerted about. And that gives you a little bit of an example of how this kind of IoT Value Added Services concept is being conceived and is trying to be developed. It's dynamic, it's deployed on the fly without disturbing. You don't need, for instance, to stop the stream and start it again, so you can actually allow the deployment of this video anonymization. You can just deploy it by press of a button as the stream is going, and you can see certain objects disappearing from your screen, blacked out of your screen, satisfying, the privacy levels of your particular cohort, viewing group privileges. All right. So last bit of this slide is to say that obviously, we're doing that in BTIRC, deploying that in Belfast Harbour, also following a path, collaboration with AWS, because most of these underlying platforms, like data exchange are built on AWS, and working on the partnership BT have with AWS, with Amazon. So therefore, whilst we're deploying things offline as proof of concepts, we are lifting and shifting them into the AWS environment to make them more native into the real BT IoT systems. So from here on after, I'm handing over to my colleagues, first Andy and then Brendan, and then I'll take over again just to start getting you through a few examples with live demos of a few of these capabilities. All right, just to give you a little bit more insight of how they work, the technical side and the application side of certain use cases we have developed in the context of Belfast Hub. So over to you, Andrew.
Okay, thanks, Aris, and hello, everyone. So I'm Andrew Ennis. I'm a researcher with Ulster, working in the BTIRC project. And I guess I'll give you an overview of one of the pieces of the Matrix platform that we're calling, which is to do with onboarding devices in a zero-touch manner. So as Aris explained, obviously there's a whole range of value-added services. The one that I'm going to focus on at the moment is the easy device onboarding or zero-touch onboarding. So the whole idea with this is, you imagine in the port environment, you could have hundreds, thousands, tens of thousands of IoT devices needing to be deployed, managed, and they will reach their end of life, or they may fail halfway through their life, etc. How do you manage those in a cost-effective way without needing a whole bunch of human resources? So traditionally, you would have an engineer go out, physically install the device. You would then have another engineer potentially configure that device and set it up and get it connected to your IoT platform. And then if for any reason that device fails, you would have to have an engineer go out and intervene and fix whatever the issue is. Might be to reset it, reconfigure it, and get it back onto the platform. But what we're looking at is how can we do that in an autonomous way, with as little human input as possible. So really it's about getting, the engineer still will have to go out and physically install the device. But once it's installed, they simply plug it in and it will automatically connect to the platform. It'll be discovered by that platform, and then the platform provisions the various settings, configurations that are needed for that device. And then it'll just start streaming its data into the IoT platform. And I guess further along in the device lifecycle, which is some of the stuff we're wanting to look at in the future, is, well, if that device fails or needs replaced or decommissioned, how can we go through the processes automatically to achieve that as well? So I'm going to give you a live demo of two devices that we have, which are also deployed out in Belfast Harbour, that we've been able to get onboarded automatically. So this is a picture I took just earlier of the basic setup that we have here, because we don't have a camera to show you. But we essentially have an edge gateway, which we're just running on a Raspberry Pi. It's built and designed that it can be scalable, so it can run on very low-end hardware, such as a Raspberry Pi, or if there's many hundreds or thousands of devices, we can scale that up to server-grade things and run it on that. Obviously, we've got our network that we're running against. And we have a Bosch camera, which is one of the security cameras that are deployed at the harbour. And we have an environmental EnviroWatch sensor, which collects air quality, noise data, light quality, etc. And then this is the screen you'll see it on it. So what I'm going to do is I'm going to share, go across and share the screen now. Okay, hopefully you'll see this come up shortly. Can you see that okay, ours?
Yeah, it
Okay.
shows right.
So
Yes.
okay, perfect. So this is the control panel that we built out. So I guess if you think in terms of automating things, generally in real production, a human won't ever need to see any of this because it'll all happen automatically behind the scenes. But for demo purposes, it's nice to be able to actually show something happening. So that's why I built the dashboard that you can actually see. So what I'm going to do is I'm going to start running this, and what you'll see is a number of devices will get found. It will then start stepping through and onboarding them. And I'll talk through the processes as it does it. Just to note, I've artificially delayed this, otherwise it will all happen within a split second, and I don't have the time to talk through it. So if I kick this off, you'll see it'll go out and start searching and trying to find devices on the network. So you'll see a whole bunch of devices. Some of them will be unknown, which are just network switches and things that we don't want to interfere with. So we just ignore those. In terms of this Moxa Technologies, that's the environmental sensor. So you can see it's found, it's recognized the device. It searched our repository to find basically the script that tells it how to onboard that device. And what it's done is it's then executed that script and started onboarding it into our IoT platform. And then once it's onboarded in the IoT platform then knows, okay, this device is on, I'm expecting data from it. And we have another process that runs in the back because this device is sort of proprietary and it only really talks to the EnviroWatch cloud. So whenever we detect it on the network, what it's really doing is actually identifying that device and getting its ID and then querying the EnviroWatch cloud. So it's basically setting up a cloud-to-cloud connector. And that's what this EnviroWatch runner does. It just processes that data that comes in from the cloud. And you'll see it being presented here in a wee moment. And then once that's done, that's it onboarded and that's it complete. Some other unknown devices, but then we get to the camera.
Hello,
so
Andrew.
similar process.
Hello,
Yes.
Andrew. So sorry to disturb you. I am receiving a couple of messages that people are not able to see your screen. Would it be possible that you can reshare, or if you have it, you can share with Eris and he can do it?
Well, because it's live, it could be interesting. Let me stop sharing and try again.
It seems it is working
that
for
should be-
few people and it is not working for
I can see it.
some other
Okay,
people.
okay. Can everybody see that now? Is there anybody still having issues?
It's coming through, right?
Okay, I can see it.
Okay, if there is any issues, maybe I can share some screenshots or something.
It's visible. Thanks.
Okay, great. Okay, so we onboarded the environmental sensor, but in terms of the camera, we take similar approach, but obviously there's slightly different variations. So we go identify the camera, search our repository. It finds the script in terms of how to actually onboard this specific type of device, and it will then execute that script and get it onboarded. And that script contains the various parameters that are needed to be set in terms of usernames, passwords, and where to send its data to. Then it obviously it's onboarded into the IoT platform. But what we then do, because it's obviously a camera, we query for the camera RTSP stream so that we can actually start ingesting frames from that camera. And what happens next is you'll see Brendan's works with video anonymization. So what we do is we basically send those frames over to Brendan's system, which you'll see in the next part of the demo. And then once that's complete, that's the device is onboarded. And as you'll have seen, I just click go and that was it. It did everything behind the scenes. But in a production system, this would just continuously query for new devices that come online, and start processing them behind the scenes, and a human never actually needs to see any of this. They would only ever see logs or details. So Brendan will talk through some of this as well, but while I've been talking there, this is the data from the environmental sensor, and you can see it's streaming in, and we're just graphing it through Grafana to show the data coming in live. And I guess I'll hand over to Brendan now for his part.
One thing to just to mention is key novelties here in terms of whilst Brendan is moving on, is all about the fact that we are continuously discovering new devices. So that's a new bit in the ZTO side of things. And one of the major things that we're trying with Andy to look into is device lifecycle management. So the next steps to ZTO, zero touch onboarding, as we call it, is to expand the management capabilities around devices for the rest of the life cycle. Onboarding is being the first stage of the life cycle, and then is the in-life parts where you got to maintain, monitor the health, monitor performance, do upgrades when necessary, manage security, manage the device, and then when it comes end of life, what is that you're doing for that and for the data streams coming off the device. So in the next phase, we're focusing specific this particular area Andy is working on. Is going to be focusing in extending ZTO into the whole life cycle management of device. That's the little key takeaway I wanted to mention, but then over to Brendan.
Yes, so as you can see, Andy has already onboarded the camera, to which he is being anonymized. So this is obviously part of the video anonymization. So as you can see, we actually have a control panel here, and I'm able to turn this on and off in order to either show Andy or keep him hidden. And the whole point of this is obviously different user groups within the hierarchy are going to have different permissions. So people like me and Andy, in regards to the harbor, we're just Joe Blogs. So we're not supposed to have any permissions to see anything sensitive. But as you go up the ranks, manager, security, more stuff's going to be more visible to them because they're obviously allowed to see the sensitive content. And it's obviously to prevent any potential misuse of the data itself. So this is the camera here, and then we're going to we have a series of different video sources. So for instance, here's a pre-recorded video, which can be used for archive footage, or alternatively, if you want to do it live, we have a live stream from Belfast Harbour at the moment. So you can see currently I don't have any cars anonymized, but if I turn them on, you can start seeing that vehicles are starting to be hid through the process. And basically what it does is it's using object detection to identify the different vehicles, and then it's basically removing them from the frames. The video source isn't really the best, unfortunately, but we're trying to get a better quality stream. Again, get back to the slides. Yeah.
Okay, so the key takeaways I would like to on Brendan's work. Brendan is looking into the video analytics area. Are you having some more to talk about?
Yes, I'm just getting up to the slides.
Sorry.
Just to give a bit more context to the scenarios.
Please carry on. Sorry, but I thought you paused there. Yeah, of course.
Oh, no. So where's the slide? Okay, so as you can see, the whole purpose of video anonymization is for itself protection of privacy, because obviously you being out in public, being on CCTV cameras, your data is being used, and we want to try and basically give control back to the user themselves to try and make sure it's not mismanaged or misused. As Irish mentioned, one of our key stakeholders is Belfast Harbour, and for Belfast Harbour, it's more of a security risk, because if anyone can access their cameras, then they're going to be able to identify what cargo's been put into what truck, where's that truck going, and through CCTV, they can potentially track it, and then possibly even steal it from the company, and they'll lose valuable resources. But by anonymizing those objects, we're able to reduce the risk, and then it makes it even harder for anyone to commit any potential theft or loss. In addition to this, we have also been using video analytics for health and safety purposes. So again, for Belfast Harbour, this is meant to reduce potential risk and injury by identifying when it happens. In there. So naturally, it's supposed to identify whenever there's any potential risk or hazards that happen on site so they can be addressed accordingly. And then this could even be paired up with facial recognition to identify what potential party has actually been injured. Because sometimes people, you have a fall to this thing, oh, nothing's really happened, but then obviously over the course of a day or two, the injury gets worse. Or at least this way it can be flagged within the system to say, Andrew fell 12:15 in section 4A, and it's obviously been flagged on the record, and it'll be, would you like to make a health and safety claim, or would you like to ignore it? So that's one of the things that a previous colleague of ours has been doing, and we are obviously then working forward to obviously combine these. And then the end goal is to hope to then use this alongside video anonymization in order to give a better health and safety and theft protection for Belfast Harbour, along with any other potential use cases. In terms of storing the videos themselves, we have the video feed exchange, which is currently being developed. And that's all about how we actually manage the archive footage that is obtained. So naturally, when it comes to the video streams themselves, very specific people are going to be able to record those videos depending, again, on permissions. So if me and Andy were on the Belfast Harbour streams, we'd only be able to view it live because we wouldn't have any rights to recording the videos, because why should we be in possession of them? Where obviously managers can decide when to be recorded, and they'll obviously get stored into our data warehouse platform, and then they'll be there and kept for archive footage in case any potential incidents come up, and the police could then turn around and say, oh, well, can we see the footage from October 1st, 2023? And then obviously we'll be able to provide that to them. And then if there's any other potential safety data that we wish to remove, we can then rerun the video anonymization again to remove any further elements that we wish to keep hidden from the police. Though really they should see everything anyway. I think that's everything for my slides.
Fantastic.
Yes. Do you want to talk about the self-healing networks of the Matrix platform? I'll hand that back over to you.
Absolutely. Thank you very much, guys. Just I think before we move on to this one, just the key takeaways in terms of novelty in the video anonymization and video analytics area. I mean, the key fantastic work that Brendan has achieved is really running all this heavyweight analytics of video at the very edge. When you hear edge, you got to imagine, Raspberry Pis and really very poor resource-wise, entities, computational entities like small pies, small gateways, and something like an AI-based technique like video analytics is very heavyweight. It's usually something that you'd run as an object recognition capability, in the cloud. Although because of the nature of the problem, that is privacy, you need to be able to run it at the edge. But how can you manage that when you don't have enough computational resources at the edge? And that's exactly where the techniques that Brendan's been developing is coming handy and make this work quite novel. So that last point of video analytics. I'm moving on to this next one here, capability, which is all about self-healing network. So the key problem here is that you have devices in an IoT domain that you control, and the thing you want to do is you want to make sure that you provide an autonomous capability to isolate devices based on the vulnerability they present. So there's also, cases where you can have hackers, coming in, taking over your devices, a DDoS attack or any type of security glitches, and that can actually make the devices being possessed. And whilst they're used on a green side of the network, something that actually allows the device to get access to everything in the network, when it's possessed by a hacker, when it's get taken over by a hacker, then it becomes a weakness for your network, right? You want to stop that. So when that's detected, based on this particular capability we have here, it's called intent-based IBMS, intent-based network management. It's all about segmenting the network in different segments, different parts, which each part, can be restricted based on policies. And on those parts, you can actually place devices that you decide after you have a kind of understanding of their vulnerabilities. All right, so if the device is okay, everything is fine, everything is running on the green. If the device though is, as I said, been attacked by a hacker, you can shift it around, not you as a human, but rather the system recognizes that, and then you can shift it around different zones, different segments of the network, which have allow you to restrict access of the device to other network resources, and therefore you can actually have enough time to heal it, apply patches, remove the malware, apply patches, remedy it, and then return it back to the right zone it belongs to. So whilst this is a self-healing process, self-healing capability, IBMS, we also have combined it with another capability that my colleague Tom Bowman in our group here at Adastro has been developing, which provides a proactive element to this self-healing process. And by proactive, we mean we try to profile its device, understand what it is they're running, if it's a passive or an active device. Passive mean like something, like a device like a mobile phone, which can show you dashboards, so it doesn't really intervene with the process. Whereas you can have robots, like robotic arms in the manufacturing process, that shift things around, and if they get hacked in, they can completely mess up the whole process. Those are active devices. So with MPIoT, an extra element of this particular capability, we're able to profile the device, understand its potential vulnerabilities. Maybe it's a legacy device that actually is not supported anymore by the vendor, but we still need to run it because the process is very critical for our job, for our business, right? Very typical scenario in a manufacturing area. However, the device remains vulnerable. Therefore, we might combine MPIoT, which gives a risk factor to the device with a certain IBMS determined segment of the network, which surrounds the device with a set of processes and policies that restricts it from for accessing more critical areas of the environment. So combining the two, we're able to take measures before the problems appear proactively, and also with IBMS specifically and solely, we're able to kick in when something goes on with the device. So a hacker hacks in, and then we can get the IBMS take over the device and put it on a stricter segment of the network, apply policies, and remedy it. Very quickly, very short, I'm going to share a little bit my screen here, where I have a few seconds of a video. I can just show you as a simulation that we have been building for this environment. So here you see how this IBMS is looks like. So there's 3 segments of the network: the green, where all devices, healthy devices, are running within; amber, which is more like a more restricted area of the network; and red is something which actually is a completely restricted segment of the network. This particular device is moving on here. Nothing can get accessed. We completely quarantine the device. So if we start, and we have 2 simulations, one controlling a robotic arm and one controlling the mobile phone. The mobile phone is accessing websites, accessing internal websites and external websites. Internal websites could be things like dashboards showing you the situation and the current status of certain processes. With internet, is common access. So based on which particular kind of the demo simulation we run, we have a device that moves around the different segments. By pressing this area here, so we place a device in the green zone to start the simulation. We simulate a DDoS attack, which we detect, and then we're going to see that the device is now moved to red, where we can then take measures to heal the device. Yeah, so we quarantine the device, try to remove the source of the problem. Okay, we start testing the device. So we place it from red to amber, so we can actually start testing it and gradually bring it back to normal. And when we're fairly sure that there's no further problems with the device, we can return it back to the healthy part of the network. Okay, so with that, that is only the IBMS side, not the MPIoT, the proactive one, but just to give you a bit of an example of how this whole thing works. So let me just get back to the slides now.
I'll share them again here.
Yes, please, if you can. Yeah, because I lost control of the slides. And then I'll be moving on to the last area and capability, which is all about SLAs, IoT SLAs. As I said before, SLAs are traditionally a network management concept. And what we're trying to do is we're trying to get the concept into the area of, oh, sorry, it's just building up the slide before I be able to move to the SLAs. So we're trying to apply the concept of SLA management on IoT services so that we can have services that actually provide classes. Please.
Sorry, are you navigating your slides? We are still on the main page.
You should be looking at.
We are on the first slide.
You should be looking at slide 22 now.
Yeah, I can see slide 22.
I'll take control.
Okay.
And then I'll.
It probably takes some time before everybody is synchronized, I guess.
Yes. Okay.
So yeah, so basically, as I said, we're trying to introduce the idea of SLAs, service level management, as a way of providing for an IoT service different classes of service. You can imagine it can be, for instance, data sampling frequency. You can have a sensor which allows you, so some people are still reporting some problems with the slides, but let's keep on the description of the, yeah, maybe if we restart, yeah, if we can reshare, I guess, the deck, or otherwise I'll move my logo.
Yes,
Yeah.
please.
Don't
I'm
take
still on
control
slide
yet,
number
Iris.
1. Yep. Now I can see that 22.
Very good.
24.
Very good. It's just a matter of restarting, I guess. So yeah,
Again,
with the SLAs,
went back to slide number 1. Sorry. I mean,
back to slide number 1.
Yeah,
So
if you
it was
hold
there
on,
just
let
for a
me,
moment and then back to 1.
yeah, let me, because I'm presenting it through mine, let me get it onto the right slide before anybody takes control.
Okay. Yeah, so when we're talking about IoT SLAs, you can imagine, any dimensions like the data itself. You might have sensors that provide you, a capability of providing samples of the data, data points per second, or data points per minute, or one data point all the way up to a day, all the way up to a week. So depending on what the sampling frequency you want to have in your data, accordingly, you can have an SLA for the service in the back of it. What is the visualization of data you offer to your customer, and accordingly, you can monetize it. You can charge for more frequent data sampling. You can charge more for less frequent, like one data point a day, which is more for statistical purposes, collecting the data for statistical purposes. You could offer it for free. You can have different costing scenarios there. But the main idea is, though, that you can control the services that you offer to different tenants. So differentiation that can drive into different charging models. And also, we have been looking at SLAs with Catherine. Catherine Peoples is the area. It's the area of Catherine Peoples is responsible for this area. I think Catherine is with us as well here. She's been looking at different aspects of SLAs. In phase 1, we looked most on the area of on the perspective of SLAs from the customer perspective. How do customers? Very good. How do customers experience the SLAs, and if there is usage of the services in ways where you can make them better offers, better SLAs, or better types of the services, matching better their profiles and their needs that we detect and we recognize from the use of the system and the IoT services, we can make recommendations back to the customers. Moving forward to the phase 2, what we're trying to do is looking at SLAs from a service provider's perspective, which is all about optimization. If you have multi-tenant in areas like a port, different types of services per tenant, loads of demand, conflicting priorities. You might have scenarios, for instance, where you have to have sustainable services, so spending less energy, but at the same time, you have to have high-performing services, which means more instances of the same service to load balance the workload across different instances of the same service, which would consume more energy. So if conflicting priorities, you know, on one side you want to save energy, on the other side you want to be high performing, which means more energy. So now we're trying to actually use evolutionary algorithms to optimize, to find this optimal balance point that everybody, all these conflicting tenants and priorities over the whole authority and governance of the port, we can offer the best balancing point and stability point in the system. Everybody's happy and still we meet all SLAs, irrespective of how conflicting they are. So with that, the last slide I want to move on is just before we open up for questions, is all about the just one slide before, Andy, if you could please. There, just a couple of words around, you know, BTIRC phase 2 shows you a little bit of the skeleton of how we want to move the work into phase 2. In phase 2, which is a thing we just started, we have different pipelines of work. The innovation pipeline of work is going to be looking, as we said before, you know, Andy is going to be taking over, you know, the device lifecycle management aspect, trying to see how we can manage devices throughout the life cycle. Brendan's area is all about analytics, not only just video, but any type of content analytics where we can actually make the make better decisions, richer insights for situations arising. So we can combine, as I said in my animated slide, you know, video streams, respecting privacy, but also combine that with time series data, events that are coming in, so that we can make sure that we have a better picture of what's going on from different sources of data. So how can you combine all this kind of stuff to make better decisions and manage critical mission critical applications? And finally, as I said, you know, we're expanding the IoT SLA management area into optimization to understand how we, from a service provider point of view, how can we make best allocation and commitment of resources so that we can satisfy all SLAs, even contradicting SLAs, and provide sustainable services and a better, you know, green environment, IoT environment. The second pipeline is all about downstream. We're going to put in a lot of effort in downstreaming the work, either internally next to the platform or externally, you know, next to customers, driving trials with Belfast Harbour and beyond. And a third, equally important pipeline is all about engineering. So we want to collaborate with BT Engineering Belfast to drive some of them capabilities in more robust implementations through the DevOps kind of cycle, so we can develop them in a more commercial, ready form and robust code, so we can actually drive products out of it, or in partnership with other vendors, who can take over, you know, the development kind of responsibility, and in a good contractual, you know, relationship, we can go to market together. So this is the sort of blueprint for as we move forward to phase 2 with the work. And I think that's concluding, actually. If you want to move the last slide, Andrew, just to say thank you very much. That's what we have to share with you. Hopefully for people who are not on the call right now, you know, we'll be able to play that back, you know, through the recording and come back offline with further questions. But let's open it up now for any questions for the time remaining that the audience might have. We'll be glad to address.
Thanks, Aris and team. There are 2 questions from Anik in the chat box you might want to pick up.
Yep, so I can take the first question, maintaining the inventory of devices. So whenever a device is detected, it's registered into the IoT platform, and that's where it maintains what devices it knows about and what their state is. So we do have device twins, where the cloud obviously keeps in sync with the device and vice versa. In terms of license costs, for our research, obviously there is no license costs. I don't know, maybe going forward, BT want to introduce licensing costs and all that, but that's above my pay grade.
Future concern, yeah. And
then maybe Iris, you can take the IBMS part.
Yeah, by all means. So the IBMS is not, as I say, you know, it's been developed as a simulation capability at the moment. So we do have demos where we show, especially the recent showcase, you know, we demonstrated the robotic arm, we did demonstrate the mobile device, you know, how to handle it. in terms of keeping an audit trail data, that's absolutely spot on extension of the capability. We haven't implemented it yet, but definitely it's what should be expected to ensure what's gone wrong and how can we, in the rectifying process, in the process of healing the device, we need to know not only what's gone wrong with the device so we can remedy it, but also how far deep and wide into the network has the problem propagated. And for that, you need to have this data to understand the extent of the problem so you can take care of that as well, eradicate the problem completely before you can release devices back to green side. So that's a very valid point. We haven't implemented that side of things yet, but it's definitely an aspect that needs to be considered. Any more?
Any more questions for Aris and team? Please feel free to raise. We still have enough time to, discuss and interact on those lines.
I see the Andrew had another question saying that how much investment has been made in tooling to manage the life cycle from a learn, buy, get, use, pay, and support, and this plugged into. Yeah, so I have to say that, and it has been admitted internally that BT is now making steps into developing the IoT business, right? So we have a platform, but now as we speak, actually in digital, internally we're organizing the specific unit which brings everything together to actually make the IoT business a more core part of the BT business, right? So all these aspects mentioned here are necessary things for the strategic roadmap of this new unit, and they're going to be making steps forward in that direction as they develop the platform, they develop the capability and the business processes on top. And it's a thing of the short-term future, I think, to be part of the underlying systems and processes, this particular concerns you're talking about here. So for the investment point of view, there is some investment. Harmony is very serious to grow this business. Only very recently, James Reynolds, I think is the name, became the IoT lead in that space. So financially, times are hard, but I guess, they have already secured investment to progress the work in that space. And I think it's just, keep an eye out for that space, to see how it's growing really. James Reynolds is one of the key stakeholders for us, from a point of view of platform. Any more? It's 2 minutes remaining. And obviously, either throw it in the chat or come alive if you want, but obviously, you can reach me offline anytime you want. I would be very glad to have conversations with you. If you do IoT work, be very glad to find out what it is you're doing so we can combine forces. You're part of the India Research Center. We'll be very glad to actually find out what your work is all about and whether we can have synergies between the research centers across the globe, all 5, but particularly the Indian one. So please reach out, be very glad to reach out and collaborate with you in any ways we can find synergies. And on that note,
Thanks.
I'd like to thank you very much for the opportunity, Sakti, for setting us all up. Give a little bit of a call out to a few people who are not present here. I had my colleague Brendan and Andy helping me with the presentation, but obviously, as I said, Catherine People is another key stakeholder. Tom Bowman is another apprentice, very star person, in the IoT team, research team in research. That's a key figure at the moment, who's involved in NP-IoT and IBMS. In the past, we had Bin Wang, who was involved in the preliminary implementation of IBMS and video analytics. And Claudia Cristina has also been a key developer, a key stakeholder as well. So as well as my colleague Mo, who's left us now, but he's really, kicked this whole thing off in terms of Matrix for the first 3 years of the program. So thank you to all of them, who are not pretty much. Some of them might be present, but I don't know exactly how many. but it's a collaborative piece of work because I think it's very dynamic, very ambitious, and definitely working very hard to make it happen. So thanks to everybody.
Yep, thanks, Aris, and your team for sharing this work with the tech community, right? And I hope that everyone enjoyed this talk. While we are talking, there is another question from Paul in the chat that you may want to
very quickly to address. Yeah, this exactly is concerns that we want to look at. I mean, Andy is looking at the moment, specifically end of life. We've recently submitted 3 papers actually to a conference that's happening. I'm co-chairing the IEEE conference in Exeter, 1st to 3rd of November. Keep an eye out. So we've submitted 3 papers that capture the latest and the future plans for that area. One of the papers is Andy's paper, which is talking about life cycle management, and some of these concerns here, end of life and security, are addressed there. We have also a second paper that details the proactive management of devices, IBMS, and MP-IoT, which addresses the security management of devices as well, which might be worth looking at. I'd be happy to share a little bit privately, though, before the papers go public, drafts. If you're interested in, please give me a note. If you're interested to share the under the wraps, keep them under wraps, but privately I can share, the drafts so you can see a little bit more detail how we view in this world, this end of the world in our work. Paul.
Okay, thank you.
On that note, we can wrap it up, I guess, yeah?
Yep. I think we are now reaching to the end of this talk. And everyone, if you do have anything to discuss further, perhaps you can reach out to Aris or me, and we'll be more than happy to collaborate and liaise. That's all from today's Tech Talk, and have a good day. Bye for now.
No problems. Thank you very much.
Bye-bye.
Thank you all.
Right.
Bye all.
Bye.